Ever wondered why some people can survive brain injury whilst others can't? What decides whether a TBI is fatal? Like if you get hit to the back of the head, are you more likely to survive than if you get hit to the forehead? What's the chances of surviving if your brain is split in two? Could you survive if the center part of your brain was damaged? And how is it that some people recover from brain injury very well whilst others become vegetables? Today we're going to do a light-hearted take on brain damage. We're going to look at all different brain regions and give a score on how likely it is that you'd survive damage to that area. And if you do survive, how much would your life suck afterwards? A survivability and a quality of life score out of 10. Now this is just my opinion based on the mortality rates and the symptoms associated with each brain injury. If you disagree with the ratings, just let me know in the comments, provide your own ratings if you want to as well. But anyway, I'm Hayden, a psychologist here in Australia, and this is my channel, Mind Cartography. Okay, if I was bound to be injured but could choose which part of the brain was to be injured, I would most definitely choose the cortex, the outer layers of the brain. More specifically, probably the frontal lobes or the parietal lobes. The mortality rates for injury to this area are pretty low. Take this famous example of Phineas Gage. He had an iron rod go straight through his skull. Absolutely destroyed his frontal lobes, but he survived. See, the frontal lobes aren't associated with any key survival functions. Don't get me wrong, they're important structures, but they're mostly involved in higher order levels of thinking. Abstract thinking, problem solving, planning, decision making. It's also a key driver for our personality. That's why after his accident, family and friends said that Phineas was no longer Gage. He also became more impulsive, irritable, unsociable, disrespectful, which made it a lot harder for people to get along with him and harder for him to hold down the job too. Within the frontal lobes, we also have the primary motor cortex, which controls the majority of our conscious muscle movements. Damaging this little strip isn't fatal, but it would leave you with paralysis in certain parts of your body, depending on where along the strip it occurs. So overall, we give the frontal cortex a score of 8 out of 10 in survivability and 6 out of 10 in quality of life. Similarly, it's easier to survive damage to the parietal lobes. It also gets an 8 out of 10 in survivability and 6 out of 10 in quality of life. Just like the motor cortex, the parietal lobes have the somatosensory cortex. This little strip is responsible for the perception of sensations like touch, pressure, temperature, and proprioception. Damaging this area could leave you with an inability to detect those sensations, as well as a general numbness and tingling. One of the more annoying changes that you might see if you damage your parietal lobes is this thing called hemispatial neglect. With this condition, you won't recognize anything on the left side of your body. Your eyes, ears, and nose will still see, hear, and smell everything on the left side, but your brain won't give any attention to it. It's as if the left side of the world doesn't exist to it. You'll only shave on one side of your face, eat on one side of your plate, write on one side of the page, and if you're given a circle and asked to turn it into a clock, you'll load all the numbers on the right side of the circle. It's weird. But yeah, 6 out of 10 because you have anosognosia, an inability to have insight that there's something wrong. Ignorance is bliss. Let's move to the back of the brain. Rate of survival for TBI to the occipital lobes is pretty high, upwards of 90%. So fittingly, we give it a 9 out of 10 rating there. Quality of life though, much worse, 5 out of 10. This is because the occipital lobes control vision, and life without vision sucks. Occipital damage can also cause this condition called achinotopsia. This causes motion blindness, an inability to perceive motion. The world just appears like a series of static images. Imagine trying to cross the road. 1 second the road is clear, the next second there's a car 20 meters away, the next second after that the car's right in front of you. That's a horrible way to get through life. Occipital damage can also cause simultagnosia. Sorry, a lot of long words in this. But anyway, this one causes an inability to perceive the whole of an image. They'll just see the parts of it. So they may see a house and only process one thing at a time, like the door or the window. If they're eating food, they'll only process the fork or the food. How do you eat your food then? Looking at the temporal lobes now, survivability is still high, 8 out of 10, but quality of life is also pretty poor, 5 out of 10. The temporal lobes control audio perception, so damage here could lead to an inability to detect and interpret sounds. Damage could also impact language, emotion regulation, memory, facial recognition, object recognition, and reward processing. Many of these functions are part of specific subsections, which we'll go into a little bit now. At the top portion of the temporal lobes, there's this little strip called Wernicke's area. Damaging this will ruin your ability to speak coherently. Patients with Wernicke's aphasia can speak fluently and make complete sentences just fine, but it's complete nonsense. Just take a look at this example.
Hi Byron, how are you?
I'm happy. Are you pretty? You look good.
What are you doing today?
We stayed with the water over here at the moment and talked with the people for them over there. They're diving for them at the moment. They'll save in the moment. He'll have water very soon for him. With luck, for him.
Next in the medial temporal lobes, we have the hippocampus. Damage here would turn you into someone like Lucy from 50 First Dates. The hippocampus is responsible for the formation of new memories. So if you break it, you'll be forever stuck in the age of which you had your accident. Here's another example of this condition.
This loving reunion happens every time they meet, and it's repeated countless times in a day, because for Clive, each time is the first time they've seen each other since he got sick.
Terry's never hugged you.
Clive's amnesia means he lives in a home for people with brain injuries, but Deborah visits as often as she can.
Wonderful kiss you've got.
Thank you, darling.
Lastly, deep within the temporal lobes, we have the amygdala, the emotional center of our brain. It processes fear and triggers the fight-flight response. If we damage this, we can't process fear, we can't recognize when we're in danger, so every day is a risk to survival. Summing up these three mini sections, we have the qual scores of 5, 3, and 6 out of 10. Okay, so that's the cortex done. Now let's move into the subcortex. Generally, the further inwards we go, the greater the impairment. First off is the hypothalamus. It controls our hormone production. Things like insulin, cortisol, testosterone, pretty vital to keeping our body alive, functioning, and thriving. Unsurprisingly, damage to the hypothalamus can cause an array of symptoms: organ failure, high blood pressure, insomnia, infertility, fatigue. There's also many others, but as you can see, some of these symptoms can be quite fatal. And given that degree of fatality, we give the hypothalamus a score of 5 out of 10 in survivability and 4 out of 10 in quality of life. Could be lower, but there's a lot of medications out there that can address hormone imbalances. Similar in name, but not necessarily in function, we have the thalamus. It's the brain's relay station. Just about all sensory information passes through the thalamus, and all information passing from one side of the brain to the other goes to the thalamus too. Above all, the thalamus is a major player in consciousness. It helps keep us awake when we need to and asleep when we don't. Survival rating, 4 out of 10. As for quality of life, well, damage to this area can leave you with a coma. Other times you may have issues with chronic pain, attention, vision loss, tremors, insomnia, speech. So I'll give it a qual of 5 out of 10 because it can depend on what symptoms you have and their severity. What about the basal ganglia? It's an area that's involved in the control of voluntary muscle movements. Patients here may struggle with balance, coordination, posture, walking, tremors. Faulty basal ganglia is most typically seen in disorders like Parkinson's disease and Huntington's disease. I've actually worked with people with Huntington's disease, and believe me, I can tell you it's a horrible condition. Patients with HD have these involuntary jerks called chorea. They can't walk properly, they can't execute basic actions like grabbing things. Think of Tourette's motor tics, but more impairing. Quick stop off in the very middle of our brain, we have the corpus callosum. It connects the two hemispheres of our brain, allowing for each side to communicate with each other. You think it's important, but you can survive well enough without it. A fairly common surgery for epilepsy is actually to sever the corpus callosum, split the two halves of our brain right down the middle. For the most part, it will cause issues with left-right coordination, but these can be easily compensated for. 9 out of 10 in survivability, 8 out of 10 in quality of life. To finish off, we have the brainstem and the cerebellum. These are structures that we evolved into first as human beings. They're structures found all across the animal kingdom because they are vital to survival. The cerebellum contains 4 times the amount of neurons than the cortex. It plays a key role in fine-tuning movements, motor learning, coordination, posture, balance. When people say practice makes perfect, it's likely because of this region. Now, you can survive cerebellum damage, not well, it's a 4 out of 10. Quality of life is also very poor, 4 out of 10. People with cerebellum damage have major issues with movement and strength. Their coordination is poor, they struggle with picking up everyday objects like a fork. Walking, speech articulation, both challenged, and there's also this condition called nystagmus, where the eyes dart back and forth uncontrollably. Just imagine the vertigo that you'd experience every day because of that. Last of all, we have the brainstem. It connects to the spinal cord, and it's an area you definitely do not want damaged. The brainstem is the center for all our vital functions. It controls our heart rate, our breathing, our swallowing, as well as our consciousness. Chances of surviving a brainstem injury are very slim. Talking about a mortality rate of about 70 to 80%. So survivability rating, 2 out of 10. Quality of life is also exceptionally poor. There's a good chance you may end up in a coma. You also may develop this condition called locked-in syndrome. Horrible thing. Full paralysis of the entire body except for your eyes. You can see, hear, smell everything that's going on around you. You can even think and understand everything, but all you can do is communicate by blinking. People with brainstem damage might also develop issues with swallowing, meaning that they are prone to choking on their own saliva, or they could suffocate because the brain can no longer detect how much air the body needs to survive. Alright, that's all of them. In summary, make sure to take care of your brain. You've only got one of them. It's quite important. If you do find yourself in an impending car crash, best bet, see if you can angle your head to focus the impact on your forehead, your frontal cortex. Maybe you could survive more likely if you hit there. But in all seriousness, if you're going to drive, make sure to drive safely, wear a seatbelt. Even still, wear a helmet whilst you drive. Why not? It's better safe than sorry. No, jokes. Just do what you can to make sure that you protect your brain as much as you can. Okay, that's another episode of Mind Cartography. Like, comment, subscribe if you enjoyed it, and I'll see you in the next video.